Okay, ladies and gentlemen, now I'm going to teach you how to calculate a slope from a graph so that you can calculate the slope from your graph that you did earlier. All right? So we are not going to be using the graph that you did when you did graphing your data for this one. We are going to be using this graph here, which I've handed out separately. This is the learning component, and then you are going to graph your own. All right, so if I write it, you write it exactly as I write it. These are notes for you to use for the rest of the year. Okay, here we go. You have a graph. It's a good graph. You have labels and units. This is a graph of speed, so it's meters and it's seconds. You have a best fit line. It has a title. Everything is ready for you to calculate the slope. So the way that you do the slope, the first thing you do is you choose 2 points that clearly lie on the line that you've drawn. Okay? The key point here is on the line. You are not going to use these points here. You're going to use your line. Second thing is the point should be as far apart as possible to minimize the impact of measurement errors. So what I do is I look for places that are pretty easy, okay? So here's one right here because it is directly above the 1 and it also lies just exactly on that line. So I am going to use that one right there as my first point. Then I'm going to go all the way to the other end of the graph and I'm going to look for another one that's really easy. So this one right here is 9 and that's very, very close to a line right there. 8. Oh, 8. Look at that. It's exactly on a line. That's perfect. So the 8 goes straight up, and then this goes straight over, and it's going to make it really, really easy to read. So I'm going to use that one as well. Okay? So here are my 2 points. All right. I have the point on the left, and I have the point on the right. And I'm going to refer to them as left and right through this whole process. Now my point should be probably at least this far apart. All right, next, determine the coordinates. For each point, identify its x and y values. We will use the terms x left, x right, y right to identify our points. So we have the left-hand point, which is going to be x and y left. We have the right-hand point, which is going to be x and y right. All right, so remember that, I'll use different colors here. Remember that this is the x-axis. And so I'm going to find where this point is on the x-axis, and it is at 1. Okay, so my x left is equal to 1 second. All right, now I'm going to use green for the other. This is the y-axis. And so I'm going to come over to here and I'm going to find that point right there. Well, this is 1 and this is 2. So remember, when we're finding the increment, we take the distance between the numbers. So the distance between the numbers is 1. Then we divide it by the number of spaces. 1, 2, 3, 4. 4. 1 over 4 is 0.25. So my y value here is 1.25. 1.25. Okay, so my y value on the left is 1.25, and I'll look for the units, meters. 1.25 meters. So if I was writing this as coordinates like I do in math, it would be x left, y left, which would be 1 second, comma, 1.25 meters. And that right there, that is my x left, y left coordinate. All right, now, as long as we've got them, let's go ahead and put them into our calculation. So x left is 1 second. X left, 1 second. Y left, 1.25 meters. All right, now we're going to do exactly the same thing for the other data point. So I'm going to find this point. I'm going to go straight down. That is going to be 8 seconds. So my x right is going to be 8 seconds. Then my y right, I'm going to have to take it across. So here I am. Now I am not looking at that point. I am looking here where the line crosses. All right. So I'm going to take it all the way across, and it's right here. Well, clearly that is halfway between 7 and 8, so that must be 7.5. So y right, 7.5 meters. So again, if I'm writing that as coordinates like I do in math, then I've got 8 seconds, 7.5 meters, and that is my x right, y right coordinate. Okay, so 8 seconds, 7.5 meters. So that's the end of my work on there. 8 seconds, 7.5. Oops, I want to use the same colors. All right, 7.5 meters. Okay, next thing. I'm going to determine the change in y. The change in y is y right minus y left. Okay, so the change in y is going to be y right minus y left. Y right was 7.5 meters. Y left was 1.25 meters. When I put that into the calculator, 7.5 minus 1.25, I get 6.25 meters for y right. Change in y, excuse me. Now I'm going to calculate the change in x is equal to x right minus x left is equal to 8 seconds, that's x right, minus 1 second, that's x left, is equal to 7 seconds. Okay, finally we calculate the slope. The slope is the change in y divided by the change in x. So slope is abbreviated m. It is the change in y divided by the change in x is equal to 6.25 meters, which is equal to change in y, always going to use units, divided by the change in x, which is 7 seconds. So I'm going to put that into my calculator, 6.25 divided by 7. And I get 0.892857, and a whole lot of other numbers, okay? Usually I'm going to do this to 2 decimal places. 2 decimal places. Here is my decimal. Here is my first decimal place. Here is my second decimal place. So what I do is I look at the number behind my decimal place and I ask myself, is this greater than or equal to 5? And the answer is no, so there's going to be no rounding. So my final answer is going to be 0.89, and here's the key, meters per second, because the top was in meters, the bottom was in seconds, so the unit is meters per second. And that is a speed. Meters per second is speed. And that, of course, is why the title of this said Speed of a Skateboard. Okay, that is how you calculate a slope. And so now you are going to calculate the slope for your own data.